The first problem on this exam you should have recognized as a homework problem. Dr. C number 2, I think, from possibly homework number 2. It says that you've got a road called our x-axis, and to find an origin. And at that origin, there's a car that's initially stopped, you see, and it's initially stopped, so its initial velocity, the car naught is 0. By the time t equals 0, it starts accelerating at a rate of 2 meters per second squared. Also at t equals 0, a truck that's been moving at constant speed and continues moving at constant speed passes the origin, passes the car. Again, its acceleration is 0, and the constant speed it's moving at is v sub t equals 15 meters per second. At some later time, because the car keeps accelerating, the vehicles will be next to each other again. That'll happen at some position that we'll call d, at some time that we'll call t sub d. So they'll both be together again. The first question is to write an equation, or a pair of equations, one of which describes the position of the truck as a function of time, the other the position of the car as a function of time. But we know that in general, if you have constant acceleration, the position as a function of time equals x naught plus v naught t plus 1/2 at squared. We proved that in class, and it's also in the formula sheet. So all we have to do is apply this to the car and to the truck. Okay, so for the truck, its original position at time t equals 0 is 0, so we don't need that term. It is moving at a constant speed vt, so vt times t, and it has no acceleration. So that's the formula for the position of the truck as a function of time. For the car as a function of time, x naught equals 0 again, v naught of the car is 0, so all we're left with is 1/2 the acceleration of the car times t squared. So that's the answer to part A. For part B, it says go ahead now and calculate these values, d and t sub d. Well, all that asks us to do is to set these two terms equal to each other, the position of the truck, the position of the car, and say at time t equals t sub d, at position car and truck equal to each other, and d, what we've got is v sub t times t, this will happen to t sub d now, is equal to 1/2 ac t sub d squared. We just have to solve this equation for t sub d. Well, that squared cancels that. And so what we have, let's write down here, is t sub d equals, multiply both sides by 2 over ac. And we're left with 2 v sub truck over a sub c. And that is one of the answers we asked for. Plug in the values. 2 times 15 meters per second divided by 2 meters per second squared. The 2's cancel, and we're just left with 15 seconds for the time when they pass. What's the position when they pass? That's x sub d, or just d. Okay. Well, you could choose either the truck or the car position as a function of time equations, but the truck one's a little bit simpler. That's just v sub t times time, which is now t sub d. So that's 15 meters per second times 15 seconds, or 225 meters is where they pass each other. Part C asks you how fast is the car traveling when the front of the car catches the front of the truck. Now, we don't have an equation for the velocity of the car yet. We have an equation for the position of the car as a function of time, 1/2 ac t squared. But you should know that the velocity is just the time derivative of the position. And so the derivative of t squared is 2t. That cancels the 1/2. So we're left with just ac times t. You could also have done this with the, okay. So A sub t, AC times t is 2 meters per second squared. The time is 15 seconds. So that's just 30 meters per second is how fast the car is traveling when it catches up to the truck. Part D says which vehicle has the higher average speed. You could almost answer this by inspection if you just know the average speed, as you should know, which is delta x over delta t, and realize both vehicles travel the same distance, 225 meters in the same time, 15 seconds. So the answer is 15 meters per second. Actually, the answer is just same for both. Okay, and of course the truck is traveling at this speed constantly, but it's also the average speed of the car. And we're done.